Hello guys, and then welcome to another video. In case you are new here, kindly subscribe, okay? Hit on the bell icon so that you don't miss out on any uploaded video, okay? So the reason why I insist you switch on your bell icon is that sometimes you might subscribe to the channel, okay? And then whenever a new video is uploaded, you might not get access to the video, okay? You might not get notified for that video since your notification is maybe switched off, okay? So in order to get access to the videos, after subscribing, hit on the bell icon, okay, so that whenever a new video is uploaded, you get access to them, okay? So without further much ado, let's dive right into this video. So this video will be what? On Thevenin'S Theorem, okay? So before I move on to Thevenin'S Theorem, I want to, clear the air on this specific problem that's really, I would say causing more harm than good, okay? So for finding what currents leaving and then what entering a node, okay? So how to use the KCL to perfection, okay? So let's look at this, okay, simple circuit arrangement, okay? So we could notice that this is a current. Let's say the current is what? I1, okay? And then this current is what? I2, okay? So in order to find this current, okay, we know that for KCL, the current leaving a node has to be equal to the current what? Entering the node. So this is our node, okay? So this current is what's entering this node. So this I1, okay? Note again that the current entering a node have to be equal to the currents leaving the node, okay? Note that, okay? So now this is the node. I1 is entering this node, okay? I2 is what? Leaving the node, okay? I2 is leaving the node, and then this current is also leaving the node, okay? So and then we know that current leaving the node have to be equal to the current what? Or currents entering the node, okay? So I1 is entering the node, okay? I1 is the only current entering the node, okay? And then I2 is what? Leaving the node, okay? And then what? This current, let's say is what? X. Let's represent this current by X, okay? So this I1 is entering this node, I2 is what? Leaving the node over here. X, okay, as a current, okay, is also what? Leaving the node. So we have what? Plus X, okay? This is how you try to solve it so that you don't get confused, okay? So just use this approach and you get all the current arrangement, okay, for each branch or each current branch or current leaving or entering node, okay? So use this approach. This is very, very simple, okay, and straightforward. So we know that KCL states that the currents leaving a node have to be equal to the currents entering the node, okay? Currents leaving, currents entering, okay? So I1 is entering this node, I1, okay, over here, and then I2 is what? Leaving, and then this X is also leaving. So in order to find this current which is leaving, that's the unknown, you just make X the subject, okay? So you have what? S to be equal to what? I1 what? Minus I2. So the currents over here will be what? I1 minus I2. I hope this is clear, okay? I wanted to clarify this during the Kirchhoff's law, but I thought most of you would understand. So this is a way of making the current arrangement or finding the currents easier, okay? So this was just by the way. Let's dive right into Thevenin's theorem, okay? Now, so for Thevenin's theorem, there are two things you need to know, okay? Only two things. I always say that Thevenin's theorem is I think is the simplest of all the theorems, okay? Right, so there are only two things you need to know for Thevenin's theorem, okay? This formula, okay? I equals VTH all over RTH plus R prime, okay? The R prime is the resistor you are being asked to find the current that is passing through, okay? So from here you could notice that This is how we represent a Thevenin circuit. Okay, we have the VTH, RTH, and then what, R prime. Okay, this is the short circuit. That's where you represent what, your R prime. Now, as I stated earlier, there are only two things you need to know. Okay, this formula and this formula. Okay, this formula, there's one. Okay, this technique 1. Okay, and there's what, technique 2. Okay, so now this is a formula work, so you can just get this straightforward. You can either memorize it, but I won't tell you to memorize it. I would rather advise you to solve questions on it, so that it will becomes part of you, okay, than to just memorize it. Okay, and then the second part is what you are normally told to try to memorize the procedure. Okay, note, there is no need to memorize the procedure. Okay, the first approach is, once you keep on solving questions on it, the procedure on Thevenin's theorem, the procedure will just come to you. Okay, but in order to learn smart, okay, trying to learn smart, use this mnemonic, okay, or acronym. Okay, RIKR. Okay, RIKR. What this simply means is that this is remove. Okay, the first R is remove, the second one is insert. Okay, so the first R is what, remove, the I is what, insert, the K is what, Kirchhoff's law. Okay, and then what, the R is what, RTH. Okay, this RTH. Okay, that's finding RTH. So we have RIKR. So you remove, I will explain later. So you remove, you insert, you apply Kirchhoff's law, and then what, you find your RTH. Okay, so for the remove is when you replace your resistor with what, your VTH. So your first method is, maybe you are asked to find the resistor in what, a certain 3 ohm resistor. Okay, the current in a certain 3 ohm resistor. So the first thing you need to do is what, remove this 3 ohm resistor, that's the R. Okay, and the second thing you need to do is what, replace the what, the 3 ohm resistor with what, your VTH. Okay, so that's the insert. Okay, so you remove the 3 ohm, you insert your VTH. The K is what, apply the KVL, okay, or KCL to find your what, VTH, and then the R is what, finding your RTH. So let's apply the method in the first example. Okay, so you remove, you insert, you apply KVL, KCL, that's a Kirchhoff law, and then you find what, RTH. So remove resistor, insert VTH, apply KVL, KCL, and then what, find your RTH. That's the RIKR. Okay, now let's move on. So for me, we have to find the current in what, our 3 ohm resistor. So all you have to do is just rewrite this circuit, okay, or redraw this circuit. Okay, so we have this. Okay, right, so we have that. Okay, and then we have this. So once you remove this, you label this what, A and what, B. So that's the first method. You remove, okay, this, and then what, you insert. Okay, you insert this. Okay, you insert. So you have what, 35 volts. Okay, so this is what I want, VTH. Okay, these are VTH. Okay, now we have what, this to what, 12 ohms. Okay, have that to be 12 ohms, and then this is what, 6 ohms. Okay, and then we have our what, VTH. Okay, the VTH moving this direction. Now, so from this formula, we know that we first remove the 3 ohm, and then we insert our what, VTH. That's right. Now that we move on to the third method, you have to do what, apply Kirchhoff's. Okay, so now let's apply Kirchhoff's over here. So since this is a short circuit, no current will pass through this. Okay, no current will pass through that. So we have this current coming in. Okay, this current coming in as what, we have what, this current coming in. Okay, as let's say I1. Okay, since no current will pass through here, the same I1 will pass through this point. Okay, the same I1 will pass through this point, and the same I1 will pass through here again, and then it will come back to the voltage source. Okay, so let's apply the loops. Okay, let's say we have what? This A, B, C, D, E, what? F. Now let's say we have what? Loop. Okay, we are applying Kirchhoff. Okay, from KVL. Okay, that's the third method. Okay, so we remove the resistor, we what? Insert the VTH, and then we apply what? KVL. Okay, now taking loop what? A, B, E, F, A. Okay, in case you've not watched a video on Kirchhoff's law, you can go back and watch it and then come back to the Thevenin's. Okay, so this one will give us what? We have what? 42 volts. Okay, to be equal to what? 12 ohm. So we have 12 times what? I1. Okay, 12 times I1, and then we have what? 6 ohm. Okay, so we have the 6 ohm. Okay, the 6 plus what? The I1. Okay, so this will give us what? 42. Okay, 42 equals what? This is what? 18 I1. Okay, so our I1 is what? I1 is 42 on what? 18. When you simplify this further, you get what? 7 on what? 3 amps. Okay, now let's use our KVL again in this portion. Okay, from the right side. Okay, so we have applying KVL again. Okay, applying KVL on loop what? On loop CBEDC. Okay, so we have what? CBEDC. Okay, so from here we have what? We have what? 35. Okay, so we are moving in this direction. Okay, moving in this direction. Okay, from here we moved in this direction. Okay, so from here you're moving in this direction. So we have what? 35. Okay, 35. Okay, and then VTH is also moving in the same direction. Okay, moving in the same direction. So we have what? Plus what? VTH. Okay, and then equal to what? Yes, we have our what? 6I. Okay, because it's also moving in the same direction. Okay, moving in the same direction, this direction of the loop. Okay, so we have what? 6I1. Okay, now we already know what's I1, but let's make VTH the subject first. So we have VTH, okay, equal to what? 6I1 minus what? 35. Okay, so we know that 6, no, I1 is what? 7 on 3, so we have what? 6 on what? 7 on what? 3. Okay, minus what? 35. Okay, so now our VTH will give us what? When you do this calculation, you get what? Minus 21 volts. Okay, our VTH will give us what? Minus 21 volts. Now we know VTH. Now let's find what the next method is, what, or the last method is what? R. That's what? Finding RTH. Okay, so for finding RTH, we just assume there are no voltages, okay, in this circuit. So we just redraw the circuit, but with no what? Voltages. Okay, we have what? The circuit in this manner. Okay, in this manner. Okay, this manner. Okay, we have what? RTH to be here. Okay, and then we have another resistor. Sorry, there's no resistor over here. That's voltage source. Okay, so we assume that there's no voltage, so we close that portion. Okay, yes, and then we know that this was 12 and this was 6. Okay, so we have 6 ohm and then we have what, 12 ohm. Okay, so there's the what, the R portion. Okay, so there's our R method. Okay, this is our method R. Okay, this is our method R. Method R. Okay, this was our what, method what, K. Okay, this was our method K. The first method was our what, remove. Okay, and the second method was what, insert. Okay, so we remove the 3 ohm, inserted our what, VTH over here, that's I. We use KVL to find our what, VTH, and then this portion is what, the what, RTH. Okay, we are finding RTH. So for RTH, we just assume that there are no voltages in the circuit. Okay, so from here you could notice that 12 ohm and then what, 6 ohm are in what, parallel. Yes, that's right. So we have what, 12 to be in parallel with what, 6 ohm. Okay, so for 12 to be in parallel with 6 ohm, we have what, this to be what, 12 by what, 6, then divided by what, 12 plus what, 6, and this will give us what, when you do the math, 12 by 6, this will give us what, that's 4. Okay, so these are what, 4 ohm. So from here we go back to the same formula. Okay, we go back to our main formula, that's I equals what, VTH RTH plus R prime. Okay, so finding the I. Okay, finding the I, we have what, I at what, 3 ohm. Okay, to be equal to what, our VTH, that's what, minus 21. Okay, minus 21 divided by what, our 4 ohm resistor, that's the RTH. Okay, 4 ohm resistor plus our what, R prime, that's what, 3. Okay, so this will give us what, when you do the math, this 721, that's 3. Okay, this minus 3 amps. Okay, so this brings us to the end of what, our first example. Okay, so this is what, the current passing through the what, the 3 ohm resistor. Okay, now let's look at our second example. Okay, so our second example might be what, an assignment problem. Okay, let's look at our second example. Okay, right, so that's our second example. So without much we do, or without further much we do, just let's just dive right into this question. Okay, so first thing you need to know is the approach. Okay, is the technique. You what, you remove. Okay, let me clear this one. Okay, you remove. Okay, you insert. Okay, you use KVL. Okay, and then you find out what, RTH. Okay, so this is what you need to keep in mind. Okay, you remove, you insert. Okay, you use Kirchhoff's law, and then what, you find your RTH. Now we want to find the current passing through our what, 5 ohm resistor. Okay, so first we do what, we remove. Okay, so that's the first method. First method is what, remove. Okay, remove. So we remove 5 ohm and represent it by what, a certain A, B. Okay, now the next thing is what, insert. Okay, so now we are about to insert our what, VTH. Okay, so this is how you insert it. So we have what, okay, we insert. Okay, take note. Okay, now let's look at how you insert. So we have 7 volts. Okay, that's have our own resistor. Okay, that's okay. We have this what 2 ohms, and then there's what 3 ohms. Okay, then we move on. We what insert. Okay, we insert our VTH. Okay, like this. We have what 2 ohm over here. Okay, and then we have what 2 ohm over there. Okay, so these are what VTH. Okay, VTH moving in this direction. Okay, now and then we continue with what 2 ohm. Okay, right, so we have what 10 what volts. Now we then insert our variables. Okay, we have what C, what E, G, what H, F, and what D. Now, so the first method is what to remove. Then we've inserted our VTH. The next is what use KVL. Okay, now the next what technique is what use KVL. Okay, now in applying KVL we choose loops. Okay, so let's choose our first loop from here, but first we need to introduce our what current sources. Okay, so from here we could insert what I1 over here. Okay, insert I1. Okay, and then from here you could notice that no current will pass through here. Okay, so the same I1 will pass through here. Okay, and the same I1 will pass through here also. Now let's start from here too. So you can notice that this current will pass through here. So we have what, let's say this I2, there's no current can pass through here. Okay, so we have the same I2 passing through here. Okay, the same I2 coming back to this point, and then it will flow backwards. Okay, so this the current direction. Current is moving this way. Okay, current is moving in this way. Now, so the funny part is the middle portion. Okay, so for the middle portion no current will pass through 2 ohm resistor. Okay, so let me prove why. Now we can notice that there is a loop. Okay, sorry, this is a node. Okay, that's a node. Now this a node that KVL for current passing through, current coming to a node, the current entering the node must be equal to what the currents leaving the node. Okay, that's what KCL. Okay, so from here we know that I2 is what entering this node, so we have what I2. Okay, this I2, okay, take note, this I2, I'm referring to this I2, is entering this node. Okay, right, so it is equal to what, and then this I2 is leaving the node. Okay, I2. Okay, this I2 is entering the node, this I2 is leaving the node. Now we don't know the current over here. Okay, so let's say this is what X. Okay, so this I2 is entering this node, this I2 is what leaving the node, and then this current X is also leaving the node. Okay, so we have what plus X. Now let's try finding X. What will be the answer? Yes, the answer is 0. Okay, so X will be what 0. Okay, because I2 minus I2 is what 0. Now this means that no current, okay, 0 current will pass through 2 ohm resistor. Okay, now let's move on. So now let's apply our KVL. Okay, so applying KVL, okay, to loop what? To loop, let's say well, alright, so applying the KVL to loop B, C, D, A, B, we have what? Our voltage source to be what? 7 to be equal to what? 2I and what? 2I1 and then what? 3I1. So you could just write 2 plus 3, okay, I1, because the current are current direction are the same, okay? So the same as compared to the loop direction, okay? So moving in this direction, so that's positive. So we will get what? This is 5I1, okay? So we have I1 to be equal to what? 7 on what? 5 amps, okay? Yes, let's move on. Now let's apply the KVL to this portion, okay? To this portion, the far left. So we have what? Loop. I have loop what? Okay, I have loop G E F H G. Okay, so we have G E F H G. Okay, so let's simplify that too. We have what? That one will give us, sorry, okay, so we have that will give us what? 10 volts, okay? 10 equals what? Current direction, okay, plus loop direction. So we have what? A certain 2 ohm resistor. I didn't write this one, so this is also what? 2 ohm, okay? Alright, so we have what? A certain 2 ohm and then what? 2 ohm. So the current are the same, so we have what? I2, okay? So we have, just like this one, we have what? 2 plus what? 2, okay? With the same I2, okay? Right, so we have a certain 10 equals what? 4I2, okay? So this further simplifies to give us I2 to be what? That's what? 10 on what? 4, which is the same as what? 5 on what? 2 amps, okay? Now let's move on to the third portion of the loop or KVL, okay? So we have loop, choosing another loop, the last loop. So we have what? This loop, okay? Now, choosing loop C, E, okay? C, E, F, D, C. So it could go in a diverse direction, okay? So let's say we choose C loop C, E, F, D, C, or we choose loop E, C, okay? E, C, D, F, E, okay? It could go in diverse direction, okay? So let's choose, you could choose any loop you want, okay? Now let's choose, but let's choose what? Loop C, E, F, D, C, okay? Loop C, E, F, D, C, okay? Loop C, E, F, D, C, that will give us this. So we have what? VTH, sorry. How about what? VTH, okay? VTH to be equal to what? Right, so we have what? CE. So we have what? The 2 is what? Positive, okay? The 2 is positive, okay? 2 ohm. The 2 ohm has what? A certain current of I1. No, I2, okay? And then note again that 2 ohm, this 2 ohm resistor has no current, okay? So whenever you even introduce the 2 ohm resistor, we will just multiply that by 0, okay? But let's just introduce it. So you have what? 2 times what? 0, okay? And then we have what? This to be what's negative because of the current direction, okay? We are moving in this direction. Note, we are moving in this direction, okay? Moving in this direction, right? So this the what? The current for the what? 3 ohm will be what? Negative, okay? So we have negative what? 3I1, okay? But we already know what? I2 and then I1. So we just substitute. So we have what? 2 multiplied by I2. I2 is what? Okay, so from here we have our I2 to the what? 5 on 2. Okay, 5 on 2. Okay, plus what? 0, because 2 times 0 give us 0. And then minus 3 on what? I1 is what? 7 on what? 5. Okay, right. So we have this, and this will give us what? A VTH of what? When you do the maths, you will end up with what? A certain VTH of what? 4 on what? 5 what? Volts. Okay, now let's move on to the last portion. Okay, so again you can choose the direction in either way. So you can also choose what? Loop E, C, D, F, E. Okay, and then you most definitely arrive at the same answer, because this will be positive. Okay, this will be positive, this will be what? Yes, negative, but it doesn't matter because that's 0, and this will be what? Negative. Okay, yes. Now let's move on. Okay, let's move on. Okay, let's take a look at something over here. So from here you could notice that this was what? We took the VTH in what? In the same direction as the what? The loop. Okay, the VTH was in the same direction with the loop direction. So what if we take the what? The how do we call it? The current or the loop direction in the same direction as the VTH. Okay, so from here we took the loop to be what? CBED. So let's do the same thing for this one, and let's see the answer we will what? Arrive at. Okay, so let's say we took loop for this one. We took loop what? We took loop what? We took loops E, C, okay, D, F, E. Okay, let's see what we will get. So we have what? The VTH. Okay, the VTH being positive. Okay, so from here we got to know that the VTH was positive. Okay, this VTH was positive due to the loop direction. Okay, from here, okay, the loop direction was positive. Okay, so we are employing the same thing right here. Okay, so now we know that VTH is what? Positive. Okay, so in case this means that we are taking the voltage direction in this form. Okay, this way rather instead of this way. Okay, so we have VTH being positive. Okay, and then we have what? 3 ohm, and then what? I1 to what? Positive, because it's moving in the same direction. Okay, so we have what? 3I1. Okay, the 2 will be what? Negative, so we have 2 times 0. Okay, and then we have what? This will be what? The 2 ohm, and then I2 will be what? Yes, negative. Okay, 2I what? 2. Okay, so from here we could notice that the VTH could be what? Negative over here. Okay, the VTH could be negative over here because of this. Okay, so because of this we have what? A certain I1. Okay, we know that I1 is what? That's 5 on 2. No, that's 7 on what? 5. Okay, 7 on 5. Okay, and then we have what? Minus 2 on what? I2 is what? 5 on 2. Okay, I have I2 to be what? 5 on 2. Okay, so when you punch this value, okay, so let's punch this value. Okay, so we have what? 7 on 5. Okay, minus 2 on what? 2 on what? 5 on what? 2. Okay, we'll notice that we have what? Minus what? 4 on what? 5 volts. Okay, I just did this so that we will verify that we need to take the direction of the VTH. Okay, so it means that this will be what? negative, okay? Yes, because our VTH, I wanted to verify. We could notice that after finding our what voltage, it was what 415 volts. But in order to verify whether the VTH is positive or negative, that's why I made us take the loop in the direction of the what VTH. Okay, so from here you know that VTH is what minus 415. Okay, just like here. So now let's move on. This was to just verify what our VTH, okay, whether it was positive too or negative. Okay, that's something we call back calculation. Okay, that's back calculation. I back calculated to verify my value for VTH. Okay, so now let's move on to the last step. That's what the R. Okay, now the R means that we are finding RTH, so just put the voltages off. Okay, putting the voltages off, we have what, let me just draw it over here so that it will be simpler. Okay, so we have what, putting the voltages off. Okay, let's just put the voltages off. Okay, so we have this. Okay, the voltages have been put off. Okay, we have a certain resistor over here, another resistor over here. Okay, this closes up, so we have what, a certain 3 ohm, and then we have a certain what, 2 ohm. Right, let's move on. So we have a RTH over here. Okay, RTH over here, and then we have what, a certain 2 ohm resistor over here. Okay, and another 2 ohm resistor down here. Okay, have another 2 ohm resistor down here. Okay, so we have 2 ohm, and then what, a certain 2 ohm. We are not done yet. We have another what, 2 ohm on top. Okay, and then there's what, just cut off. Okay, the voltage source is just cut off, so we have 2 ohm. Now this is the trick. Okay, from here, so we know that we are solving for what, the R. Okay, this is the R method. Okay, so now from here we know that what, this 2 ohm and then this 2 ohm is what, they are in what, parallel. Okay, because when you traverse through them, okay, in case you've not watched our first video on what resistors in series and parallel, you can just skim through to that video and then come back to this. Okay, so when you traverse through this, okay, when you traverse through this, both 2 ohm and 2 ohm, we could notice that what, there is no what, other element. Okay, because the voltage sources have been what, cut off. Okay, now and then again, this 2 ohm and 3 ohm are in what, parallel, because when you traverse through them, there is no other element. Okay, so the thing is, since this 2 ohm and this 2 ohm are in what, parallel, and this 2 ohm and 3 ohm are in parallel, once we find this and then find that it will be in what, series with this 2 ohm. Okay, right, so this will be what, 2 ohm will be in series with, parallel with 2 ohm, plus 2 ohm being what, parallel with this 3 ohm. Okay, and then we have what, that's being what, series with this 2 ohm. Okay, so this is how it's going to be. So we have what, 2 times what, 2 divided by what, 2 plus what, 2 plus 2 what, times 3. Okay, divided by 2 plus what, 3, and then what, plus 2. Okay, we could just also write it in this form. Okay, could just write it in this format. Okay, since the 2 ohm is in the middle, okay, could just write this 2 plus what, 2 times what, 3 divided by what, 2 plus what, 3. So from here we'll get what, a total what, resistance to be what, when you do the calculation. Okay, there's 1, there's 2, so we will have something like 21 on what, 5. Okay, 21 on 5 ohms. Okay, 21 on 5 ohms. That's our what, resistor. Okay, or resistance. So now back to the what, the equation again. That's from this equation, okay? So from this equation we have what? I, okay? Let me write this in what? Perfect color. So we have what? I to be equal to what? V what? TH, okay? Divided by what? RTH plus R prime, okay? And that's what? VTH was what? Let's find our VTH. We had our VTH to be minus 4 on 5, okay? Minus 4 on 5, okay? That's minus what? 4 on what? 5, okay? And then divided by what? RTH. RTH is what? Yes, that's 21, okay? On what? 5, okay? And then plus what? Our 5 ohm resistor, okay? So that's 5, okay? So let's punch this and see what we will get, okay? So we have minus 4 on 5. This will give us something like close to 0 point something, okay? So we have that, and then we have 21 on 5. Okay, so we have minus 4 on 5, okay? And then we have 21 on 5, okay? And then plus 5, okay? So we'll get our what? Current will be what? 0 point, okay? 0.0 what? 8 amps, okay? 0.08 amps, okay? It could be 0.09, okay? Could be, because this is what? Let me write it in full, okay? So this 0.08, okay? 696, okay? So we could just simplify this to what? 0. What? 0 maybe 9, okay? 0.09 amps, okay? Note that the current could be what? A negative current, depending on where the current direction is flowing, okay? So this is negative, and then it could be also positive, okay? The current, note that the current is negative as a result of the current direction we took, okay? And then the current could be positive due to the current direction we took, okay? So during the exams, and then maybe the final answer is 0.09, and then you had minus 0.09, you could be correct depending on the current direction you took, okay? So in case, let's say, okay, so from here we took the current direction to be what? Going this way, okay? In case we took the current direction to be the opposite direction, we would have gotten I to be what? Positive, okay? So thanks a lot for staying with me till the end of this video. Kindly subscribe, like, let me know your questions in the comment section below, share, and then I will see you in the next video. Have a good day. Bye bye.